vestibular structure and function. Vestibular system also utilizes hair cells, endolymph, and they will utilize the same endolymph that comes from the structures associated with hearing, such as the cochlea. The different structures that we need to be concerned with here are the 3 semicircular canals and the otolith organs. And the otolith organs are the processes that are on the base of the semicircular canals. Vestibular hair cells work a lot like auditory hair cells. The only difference is that they always have a resting membrane potential and a resting discharge of frequency of action potentials. So even if they haven't been stimulated in one direction or the other, you will still have a resting discharge. If you activate them, you will get an increase in resting membrane potential, and you'll get an increase in the number of volleys of action potentials sent to the nerve. If you then go back down to a basal condition, you will still have a volley of action potentials sent to the nerve. If then you hyperpolarize it by bending it in the opposite direction, you will slow down those nerve impulses. So here we have a couple of signals. It's always on, and if you tilt it in one direction, you get depolarization and increased volleying of frequency. And if you tilt it in the opposite direction, you get a hyperpolarization and a decrease in the frequency of action potentials. So how can we use this to better understand our direction sense and if we are spinning in space? Our semicircular canals allow us to understand where our head is in terms of rotation. Is it still? Is it rotating to the right or to the left? Are you spinning? These are important items to have good information about. How the hair cells work in semicircular canals is the hair cells are in a small pocket at the base of each of the semicircular canals known as an ampulla. The cupula is a small gelatinous structure located above the hair cells. Then you have endolymph that's going to be passing through these, and as the endolymph deforms the cupula, it will bend the hair cells. How do you know which direction this is going to occur? If you are having the head rotate in one direction, the fluid will start moving in that direction. And as that fluid moves through the semicircular canals, that is what will bend or cause the cupula to move, which then bends your hair cells. You will have some hair cells that are facing in the direction, having its tallest component in the direction of the fluid flow, and then you will have some who have this tallest component in the opposite direction. So you're always going to get some signal. Sometimes you're going to get from the same ampulla structure, some hair cells are going to give you a positive signal of their depolarizing, and some will give you a hyperpolarizing. This is then summed, and you can have a coordinated response to that particular stimulus.